Hello. Hi everyone, welcome back to my YouTube channel. Now this video I'm going to show you the sine A plus B is equal to sine A cos B plus sine B cos A. You say, for example, you want to add sine 30 plus 45 degree. Why is it that it's not equivalent to sine 30 plus sine 45? It is not going to be equal, right? Let's say, for example, what is sine 45? Sine 75 degree is, well, I do not have a scientific calculator, but I can use a Siri. Let me ask Siri. Hey Siri, what is sine 75 degree? So that's the answer. 1 plus root 3 over 2 root 2. So that's the answer for sine. Okay. However, if I want to find out what is sine 30, well, I think you should know by now sine 30 is actually 1 over 2, and sine 45 degree it's 1 over root 2. So if I want to have what, 1 over 2 plus 1 over root 2, well, the answer would be what, 1 plus root 2 over 2, which is not the same. I mean, the answer here, this one and this one, they are not the same. While you are watching this video, you should actually have your compass, set square, and your ruler to try to draw this diagram. I'm doing on the left hand side here. So to start off with, I'm going to insert a circle on, and then I move it aside. I mean, I do not need so much of space. I mean, I just need the first quadrant, right? Then I would also insert x and y axis for simplicity. So this is where it starts and then end. Okay, so the axis you have, and x and y axis. And if I were to insert a line from here to here, this one here would be the radius. If I were to insert another line to here, possibly here, okay? So I make two lines where the first angle here is alpha, and then this angle here is beta. So how do I find out the total angle alpha plus beta here, right? So this is the video about it. How do you prove it? So in order to do that, what happened is I'm going to add a few more lines. First one here, draw a vertical line down, use a set square, make a 90-degree line here to make a first triangle or line, alternate angle. This is actually alpha plus beta. And of course, this blue line is the radius r. So therefore, this is right 90 degree. So therefore, this length here, OA length, my OA length is actually, you can use my what, sine alpha plus beta is actually the OA length. I mean, if you have watched my previous video, I talk about how do you get those length, right? This length is actually a line. Oh. So now, therefore, the OA length will be equals to, you bring this, the denominator r up, it's r sine alpha plus beta. I mean, maybe this is one of the important things to do. If I were to drop a perpendicular line here to here, from this E point to the OC length, and make sure they are perpendicular. You may use a set square to draw this line perpendicular to here, and then draw a line from here to here. Okay, and hence, if I know this length of DE plus, draw another perpendicular line, F and G. Okay, so if I know this OA length is actually equal to DE length plus FG length, right? So you don't mistaken about this line. I'm not talking about this length, this CB length. CB is actually the length of R. So this OF length is not R anymore. So now I may want to erase off this R to avoid any confusion. Then if this is correct, it's definitely correct. OA is DE length plus FG length. Since this is 90 degrees, so this angle will be 90 minus alpha. And then if it's 90 under alpha, so therefore this is parallel to this line. So I have alternate angle. So this length, this angle is also alpha. Zigzag rule. This one here is also parallel to with this line. So we have alternate angle. And if that's the case, since this is 90 degrees, so therefore this angle is 90 minus alpha. So I'm not going to write it here. It's too small. And this angle would be alpha. Right? This is 90 degrees. This is alpha. 90 minus alpha. So this now angle will be alpha. So if when this is true, then I'll be able to find out this length. But just before that, I must find out EF length. So this EF length would be equal to actually R sine beta. Right? This triangle is 90 degrees, so R sine beta will be this length. Now if I know this length, hence and therefore, I'll be able to find out my DE line. And my DE line would be, write down, this is cos, isn't it? Cos beta. So if I use another color, I extend this line to here. So this length of DE is actually R sine beta cos alpha. Cos, isn't it? I mean, if I have a triangle, this is alpha, this is R sine beta. So this length is actually, we take the cos alpha is the x unknown over R sine beta. So now therefore my x unknown, x will be, you denominator bring it up, it become R sine beta cos alpha. I can easily prove it here. Right? So this is how I get this length. So if I got this length already, now I'm left with this length of FG length. FG length here, will you agree with me that this length is actually, you take this length to here, isn't it? There's a triangle here. But the problem now is I do not know this length of OF, right? So this OF length, okay, this OF length is a triangle here. this length is actually r cos beta, right? Again, reference to this triangle, right? They're using the same way. I will be able to find this length. It's r cos beta. And I know this length is r cos beta, then this length of GF length is actually equals to r sine alpha cos beta. Right? Why is that so? Prove it here. Triangle, hope you can see, where this length is r cos beta, and this is the alpha length. So this x unknown would be sine alpha is actually x over r cos beta. So I bring it up, rearrange them. So my x length would be r sine alpha cos beta. That's why we have this length here. So I know what is this length already. And I know what's this length already. I put it to here of OA. So hence and therefore r sine alpha plus beta, which is from here, this length is actually equal to dE, which is sine beta cos alpha, factorize and simplify, and hence identity, therefore sine alpha plus beta is actually equals to sine alpha cos beta plus sine beta cos alpha, right? So this is how this identity is being proved. If this is your first time watching my video, kindly subscribe to my channel and appreciate a thumbs up. Stay tuned for my next video.